Hey everyone, Chris Bennett, Blockchain Beard Guy here. I wanted to take. All right, take two. Hey everyone, Chris Bennett, your Blockchain Beard Guy here. A little while back, I did a video showing everyone Etherscan IO and what actual real life Ethereum transactions looked like on the Ethereum blockchain. And I got a lot of positive feedback. A lot of people really enjoyed that video and wanted to dive a little bit deeper into seeing what a decentralized app might look like. So, this is something I've been meaning to share with everyone here online for a while. When I first got into blockchain, I wanted to build a sample app that I could take and show people and let them click and play with, and have it be something that was not cryptocurrency, so folks could start to see that there were more use cases out there for blockchain besides just cryptocurrency. So what I did is I built an Ethereum-based elections platform, and I want to show that to everyone today so you can see what a working decentralized app looks like. We'll look at how the app works. I'll give you a short tour of it, and then we can peel back the layers and see a little bit of the code. You can see the smart contract and how that works, and hopefully that'll give everyone who hasn't built an app like this yet a little more better idea of all the pieces and components. So the first thing that I'm going to do here is I'm going to start an application called Ganesh. And this used to be, up until very recently, called Test RPC. But all this is it's an application you can put into your development environment, and it runs a blockchain local on your computer. So it's really fast for testing, and you can watch different amounts be traded in and out if you're building a sample token application. It's just a great way to test locally before you put something on the test Ethereum network. And I'm going to pull up the transactions tab here, and that way we can actually see every time a transaction is made to our local blockchain. And you'll see right now we don't have anything. Now the other thing I'm going to do is I'm going to go out and I'm going to deploy my smart contract that runs all the elections. So you'll see here as I compile and deploy my contract, we will see a transaction hit our local blockchain, and that's the smart contract being deployed. And there you see it. So there are actually two contracts that got deployed. There's one called migrations, which is actually the framework to move my smart contract, vote Ethereum, onto the blockchain. So that's what we see here. Now I'm going to go ahead and start the dev environment. And all this is doing is starting a local web server on my computer, so I can actually pull up a web page. I'll start Google Chrome, but you could use any browser for this. My test environment here is running on Linux. It's an Ubuntu installation, and I would recommend that to anyone who wants to get started developing on blockchain. There's also a lot of support and information out there for folks on a Mac, but not quite so much for you folks on Windows. So here's the main page of my application. On the dashboard, you can see different parameters. None of these have been set, so start and end time for the election. One of the interesting things about these blockchain applications isn't necessarily, in my opinion, the blockchain technology itself, but it's some of what you can do when you re-investigate and re-engineer old ideas, voting being one of them. So in the United States, at least, there's a lot of discussion every year around our election day. We have it on one day, on a Tuesday, and there's a lot of concern that this disproportionately affects lower income people more than it does high income people, because high income people can more easily afford to take time off work and wait in longer lines to go vote. The point being that if you run all this electronically on blockchain, you can have a start time and an end time, and that doesn't necessarily have to be a day. That could be a week, 2 weeks, 3 months, whatever you wanted it to be. We have real-time results, and this is just something we can set to determine whether we can pull back election results while the election is in place or not. and then max votes per election. And all this is if you think about most elections right now, you just get one vote. Everybody gets one vote. This actually allows us, if we want, to give people more than one vote so they can spend it. Maybe there's 3 candidates and you really, really dislike the third candidate and you really like the first candidate. So you have 100 votes to give. You may give 80 to that first candidate and 20 to the second one, just to kind of hedge your bet that the third one doesn't win. Again, not saying this is the best way to run an election, but just when you use blockchain or when you use technology to go back and reinvent old ideas, there's some cool possibilities. The other thing I'll show you real quick on the dashboard here is we have many different people that we can select. So I can decide to be Carol or Doug. And then we have the chairperson. So there are certain things that any of these voters, such as Alice or Bob or Francis, can do. And then there are things only the election chairperson can do. So I'm going to start as the election chairperson, and I'm going to configure my election. So I'll click on this second tab. I'm not going to worry about the start or end time. I've actually got the checks for that in the code commented out because it makes testing and demonstrating this app a little difficult. But what I will do is go ahead and set the maximum votes per election. I'll set that to 100. And you'll see here that when I did that, that wrote some information out to the blockchain. And I can actually pull up a browser, and I can see, this is just like when we looked at Etherscan. We're getting all the same information here locally. So I can see what happened. And I get my confirmation here in the app. And then I'm also going to set the real-time results to true. And then let's go ahead and set up an election. And we're going to have an election for your favorite Star Wars character. From episode 4, meaning the first Star Wars. And I'm going to go ahead and add some candidates. I can come back here and see what my elections are. So just so I don't have to do a lot of typing, I'm going to copy this. Then we're going to start adding candidates to this election. So we'll add Darth Vader. You'll notice each time I'm doing this, there's a call out to the blockchain. So let's add one more candidate real quick. Let's add Luke Skywalker. And there's our transaction on the blockchain. And just like in Etherscan, we can see the transaction data. So I'm going to highlight all this transaction data. I'm going to copy it. And if we go decode this, we can see there is the election that we want to add a candidate to, and there's the candidate. So this gives us a way to go and validate all this information on the blockchain and make sure that everything is getting added fairly. And then I'll show you some checks in here because when I get into the code, I want to show you how these work. So I'm going to choose a voter. Let's say I'm Alice. And Alice is going to try and add a candidate. Let's go get our election name again. And she's going to try and add Princess Leia. And you'll see here it fails. Only the election chairperson can access this function. This still tried to write something to the blockchain, so we do get an immutable record that someone other than the chairperson tried to add a record, and they were denied. And now, our voters can go begin to vote. So let's say I'm Alice, and Alice really likes Darth Vader. So she's going to give him 90 points, or 90 votes. And maybe she wanders off and she forgets how many votes did she already cast for Darth Vader, so she can check her balance. And she can see that she's already spent 90 votes. And if she changes her mind, she can uncast her vote for Darth Vader. And then if she checks her balance again, she spent 0, so she has 100 available. So maybe she decides she wants to give Darth Vader 99 of her votes. And she'll give Luke Skywalker 1 vote. At any point, because we set the real-time results to true, the election chairperson can come and see how the votes are being tallied. Okay, so let's do one more round of voting. We'll get Carol in here, and she'll do some voting. And Carol likes Darth Vader a little bit, so she'll give him 25, but she's more of a Luke Skywalker fan. So she's going to give him 75. And there we can see the real-time results. So with 2 voters voting all their votes, right now it looks like Darth Vader's a little bit ahead. And of course, all of this is all tracked on the blockchain. So again, we can go in, look at any of these votes. We can see there is the election she was voting in. And if we decoded this first piece as a decimal number instead of ASCII, we'd actually see the balance, or how much she voted, the number of points. So it works just like when we looked on the test Ethereum network, except it's all running here local. We have records of everything. And that's a quick overview of the app itself and how it works. In the next video I do, which will be the second part of this series, we'll get into the code and we'll look at how all this is structured and what the smart contract looks like. So I hope everyone you found this useful. I hope you tune in for the next video. If you have any questions, let me know. Shoot me a message, or even better, put up a post, tag me in it, and that way we can share the answers with everyone. Until next time, this is Chris Bennett, your Blockchain Beard Guy.